Good evening, everyone. My name is Daniele Vantaggiato, and I would like to clarify one thing immediately. There is a reason why this presentation has been inserted in the closing. The reason is the following. The project I am going to present you will have fascinated and intrigued to the point that you would not be able to follow all the other presentation with due attention. Now that we are at the end, this danger was averted, and so we can start. First things first, in 1960, don't worry, I promise that I will be brief. I will cover 50 years in just two slides, trust me. In the early 1960s, Mr. Fernando Corbato helped deploy the first known computer password. The situation was as follows. Everyone at MIT shared the same mainframe and one shared disk file. So there were two problems to solve. A way to authorize the software to read only the data of a specific user, and a way to keep people from using too much the mainframe. Luckily, after 50 years, the preconditions have completely changed. So the question is, why haven't login protocols evolved? Let's take a closer look at the basic login flow, a process so simple that no one ever tried to improve it until now. More or less, this is the flow simplified that each login follows. No matter how strong a password is, no matter how many passwords there, the last check of each login is always the same. If the password communicated by the user corresponds to the copy inside the DB, then the software must allow reading the other data and doing something. Now, I have nothing personal against the select query. In fact, I love MySQL, but I think that at this point it is a legacy. And that in a world where everyone carries a lot of gigabytes with them and is well connected to the internet, it makes no sense to save our information in so many remote databases and then use so many strong and hopefully different passwords only to authorize access to them. While most of you focus to improve or, depending on the rules, to weaken what happens before or after this query, we have created a login flow without this query and without a password verify step. Let's see which objective we set. We believe that only you should have possession of your data, that your smartphone should be the guardian of your privacy, and that whoever wants to read your data must ask for permission directly from you. Keeping faith with this principle, we created a flow where data is not stored on a remote server, but on your smartphone. Subsequently, we make possible a direct remote read access to your storage without the need to trust any third party. This change, which might seem like a simple exercise in style to someone overly concerned about privacy, instead solves all the problems that revolve around sign up, login, and authorization. And we do that in only three steps. Step 1, the user experience is as follows. User install the app and enter their data like name, surname, credit card number, addresses, and so on. Please take note. I'm talking about data, not password. User will never have to see a password again. When the user installs the app, they are assigned a short username of HR that we call single ID. What happens in the backend? Together with the single ID, user devices are also assigned an encryption key by your server. This encryption key is not stored on the user device, but every time the app is turned on, our server sends the key back to it. Data is only stored locally, encrypted with AES, so we have the key and the user has the data. And this means that even in the case of data breaches of our DB, the user data will continue to be safe in the user pocket. Step 2. Whoever wants to read the data directly from the user device must embed a login with single ID button on the login page. Technically, it's an A-frame with PHP and JS that must be hosted on the recipient system, and you can do that with a simple git clone from GitHub. Unlike all other buttons, login with Facebook, Twitter, LinkedIn, this button allows the recipient system to receive data directly from the user's smartphone. The process is kicked off when the user clicks on this button and enters his 8-digit single ID. And this is what happens in the backend. The PHP creates a random 32 char string that we call UTID, as for unique transaction ID. Then the PHP does a post call with CURL to our servers. We do some formal checks and then we forward the received data together with a push notification to the corresponding device. After the post call, the iframe refreshes itself every few seconds looking for a file called like the UTID value, a file that for now is non-existent. Final step, front end. A push notification will wake up the app and a yes/no question will be displayed with the data that has been forwarded to the device. This website has requested your personal data. Would you like to send it now? If the user clicks yes, the app will do a post call to the target URL on the recipient system with the data stored inside and the UTID. Please know that no user data will be transmitted over our servers and no user data are stored on our server. So knowing the UTID cannot permit us or an hacker inside our server to log in with the data of another person. Final step backend. The data sent from the user device will be stored as a JSON array in a file named like the UTID value. Like that, the other session that refreshes itself can now read the data sent from another browser device's session. The UTID could be compared to the session ID that usually is stored in a cookie after the password verify step. But this time, he's saying, is to combine two different sessions, maybe from different devices or IP addresses. It doesn't matter. Doing so, we give a read access to the data saved on the user device. Let's recap everything with a scheme. The recipient system is anyone who embeds the login with single ID button. When the user inputs his HR single ID in this button, the iframe will create a random UTID and will kindly ask to our server to forward it to the corresponding device. Our server then creates a push notification which is sent together with the UTID to the user device. If the user accepts, his data stored inside the app only are sent directly from the user device to the recipient system. While until yesterday the password verify step represented the authorization mechanism for allowing the reading of data already stored in the recipient system, we have transformed that mechanism into a simple yes/no question. Now, that authorization is implied by the user sending his identification data in response to that yes or no question. Sign up and login are indeed one and the same thing. They have been merged into a single step. And this is a sign up experience on the Deutsche Bahn websites without single ID. If you want to buy a ticket on the Deutsche Bahn website, you need to do a sign up first. And this is a process so boring, so time consuming, so tedious, so useless that you will need at least 2 minutes, 2 minutes and a half on a desktop to complete. It is so boring that we need to skip and to go forward because it's too much boring, definitely. You need 2 minutes. Take on mobile. Instead, this is the same process on the Deutsche Bahn website with a single ID button. You will put your single ID on the single ID button. You will receive a push notification on your smartphone and a yes/no question will be displayed. And if the user clicks yes, the data will send back to the website directly, and a little bit of JavaScript will take care of put all the data into the right fields, and you will need 50 seconds instead of 2 minutes. The advantages of that solution are evident, and I want to highlight just a few. Decentralized, granularity, passwordless, not even a single master password. No more data breaches, because websites can now delete sensitive data of their customer at the end of the session. Consequently, we are completely zero knowledge. Our servers do not know or own, not even in an encrypted way, user data. And our solution is as close as possible to the 25 features that a perfect authentication scheme should have according to the quest to replace password. With our solution, a user must indeed never create, memorize, see, or type a password again. We all know that many companies are trying to make login passwordless. Yahoo has switched to SMS, Medium has switched to a throwaway link in email. That seems to me not very comfy. Amazon now offers a login with registered phone number, but our solution is the only one that offers login with simultaneous data onboarding. Simply by moving data storage from several remote servers to the device in our pocket, we have solved all the usability problems that are discussed in events like this. The result is that, like today, where if you are enrolled in 100 sites, you have to write 100 times your data, and you must have, hopefully, 100 different passwords. With single ID, the 100 websites will, at each login, ask you for a read access to your data. The trick is simply decentralize storage and give a full read access to whoever requests it each time. This trick, by the way, is now a USA patent. The good news is that the app is already done for almost any platform, and the access means that I'm afraid for BlackBerry user. The API are ready. The code of the login button is available on GitHub in its first release. Now that we have built the product, we need distribution. Try it for yourself, play around with it, spread the word.
That's all. Thank you.
Questions? Anyone else? So if I understand correctly, your server knows the IP address and probably the identity of the server that the person's logging into. And you also have to know who to send the push notification to. And if I'm correct about that, then you have the capability to know who is logging in where. So there's a huge amount of tracking capability built into the system. And do you have any way of addressing this, or have I misunderstood?
No, we are completely zero knowledge because on our server we have a tablet consisting of the 8-char single ID, the push ID of the app installed on your device, the plain text password that encrypts your data, the decrypt hash of your email address only if you enable a remote lock feature, your smartphone IP address, and which website asks you to access your data, but we don't know who are you and if you will click yes or no. So we cannot track. Yeah. Sorry, man.
You know the person. The question was, you know the person.
No, I don't know. I cannot know the person.
You're charging for this service, yes?
No, it's free.
There's a link between the single ID and the phone device. The links between the single ID and the phone device. That tuple is now. The 8-character single ID. You know which phone device corresponds with the single ID.
Yeah, I know the push ID of the app installed. So I cannot know which device, Google or Apple, can know which device corresponds to this push ID. But I don't know. And I cannot know.
I have another question. That's about privacy. How do you? Well, maybe I didn't get this all right, but how do you prevent the user from losing access to their stuff? If I lose my phone, if I don't have a backup of my phone, so because it appears to me that my identity is somehow on my phone in the single ID app, but if somehow my phone explodes, there's no recovery from it, or what?
There is, it's not a locked out. If you lost your phone, you're not locked out of your website. And because inside the phone there are no passwords, there are your data, your name, surname, address. But maybe it's the same case. This is a little bit different, but the idea behind is the same. If your servers go offline, you are not locked out. If you lost your phone, you can also do a request to the website saying, "Oh, I forgot my password. Send me to my email," and you can enter on the website again using an old password style. Then you can associate inside a new single ID when you buy another.
Is it fair to say this is not so much a login system as it is a kind of secure automated form fill system?
Spot. We match.
Yeah, so my question is actually kind of related, which is that, I mean, it seems that you're transforming relationships into transactions. Like Deutsche Bank, Deutsche Bahn, if I want to buy one ticket and they delete everything at the end of the transaction, and then I buy another ticket, that's fine, right? There's no sense of relationship. If I'm and that might have, but if you want to go to Deutsche Bank, or if you want to go to say something like Netflix, where I'm going to have a queue and there's going to be sending me stuff, right? How does it work that you delete all of that the end server deletes all of the material at the end of the process?
The remote server can delete the sensitive data about the sensitive data that why store a credit card number when the user will send again and again each time. But
so by default, they'll keep it because most of their users won't be doing that, and they want to make it as easy as possible. It's having that data is a competitive advantage that is relying on.
Sure, having all the data each time, but delete the sensitive data of your customer. If you think about liability and data breaches, it's convenient to remove credit card number from my DB.
I think what he's saying is that, so for Netflix, you don't want them to delete your credit card, right? Because there's that recurring payment aspect, just a convenience. But my question is, so let's go back to the server. So you currently have a portion of an AB key mechanism, right? So PKI of some sort. You have a key on your server that's associated to an IP, and that's associated to that the phone ID for the app. So the app installs and generates that unique ID. So if an attacker was capable of compromising the key required to plain textify the stuff stored on my phone, wouldn't they, in compromising that key, also have access to the unique identifier of my phone via the IP that you store next to that key?
In this case, the attacker needs to compromise two different systems, our server and contemporary your phone.
I still see.
I'm going to cut it. You will also be around for the evening, I guess.
Yeah.
Yep. So, I mean, again, let's give him a round of applause.
Thank you.
Yep. As I said, auction wrapping everything now at 7, posting remarks in the chill out room, and no, the pool party sponsored by Honor.